So in today's video, let us discuss about the radius of nth orbit of Bohr model of hydrogen atom. So let me consider a circular orbit like this. Let r be its radius, and if z represents the atomic number, then there will be actually z number of protons. So whatever be the atomic number, there will be that much number of protons. So the total charge of the protons, or you can say total charge of the nucleus, will be z times the charge of a proton, where E is the charge of a proton, and that will be positive Z to be precise. See, there is a nucleus here and the charge of the nucleus will be Ze, because there are only protons and neutrons inside the nucleus. Since the neutrons have no charge, they won't contribute to the total charge. So the total charge of the nucleus will be plus Ze. Clear? And we have an electron E that also have the charge E orbiting along this nucleus. Since its charge is negative, this electron gets attracted towards the nucleus like this. Okay, that's actually the electrostatic force of attraction. And we know the magnitude of electrostatic force of attraction will be K times, that is, this K is actually electrostatic force constant, K into Q1 Q2 divided by R square. This is the general formula, but we know Q1 is Ze and Q2 is E. I'm right now taking only the magnitude. So F is equal to K into Q1 is Ze into charge of electron is E. I'm not taking negative. We are interested only in finding the magnitude of the force, okay, by R square. So Fe will be Kze square divided by R square. Okay, that's actually the magnitude of the force. Okay, let's call that as equation number 1. And we know for the electron to rotate like this, rotate with a velocity v, there should be a centripetal force. Whenever, only with a centripetal force, any object can rotate about a point. Let's take this point as O. Let the center of the nucleus be some point O. So in order to rotate along a circular path, there should be a force called the centripetal force. We represent that as Fc. And we know the expression for centripetal force is mass of the body times velocity square divided by radius. Okay. So who is actually providing this centripetal force? It's actually provided by this electrostatic force. So they must be equal. So we have Fe equal to Fc. Okay, magnitude of Fe equal to Fc. So I can equate equation 1 and 2. So I have mv square by r is equal to kze square divided by r square. I can cancel one of the r. Then the expression for, if I take this r to the left, I'll get mv square r is equal to kze square, or I can write r will be kze square divided by mv square. Let's call this as equation number 3. Now we have From Bohr's quantization principle, this orbit is a stationary orbit because the electrons do not radiate energy. So the condition for a stationary orbit is, or we can say Bohr's quantization condition, Bohr's quantization condition, that's actually the angular momentum must be an integral multiple of h by 2 pi, or you can write L equal to nh by 2 pi, where L is the angular momentum. N can be 1, 2, 3, etc. Okay, depending upon the orbit. And we also know L is equal to mvr. Angular momentum is mvr for circular orbits. That is, mvr is equal to nh divided by 2 pi, or you can write r is equal to nh by, taking this mv to the right, you will get 2 pi mv. Call this as equation number 4. See, this equation 4 and equation 3 are both same because they represent the radius. Okay, so that I can equate equation 3 and 4. That will give equation 4 equal to equation 3 implies nh by 2 pi mv must be equal to kze square divided by mv square. Clearly this m will get cancelled and one of the v's will get also cancelled, so that I can take the v left here to the right. Then it will be nhv is equal to, take this 2 pi to the right, that is 2 pi k ze square. Or I can write v equals 2 pi k ze square divided by nh. Clear? Let me call that as equation number 5, taking this nh to the right. Now, let me erase here. Now, let me plug the equation 5 in equation 4. That is, substitute equation 5 in equation 4. Then I have r is equal to nh divided by 2 pi m into c. Instead of this v, I can plug in this value, equation 5. So, v will be 2 pi k ze square divided by nh. Okay, this nh will move up, so that will be nh into nh divided by, this will be 2 pi into 2 pi is 2 pi into 2 pi. I'm rearranging the denominator, 2 pi into 2 pi m k z square. Clear? So simplifying this, you will get r equal to, see this nh into nh is n square h square divided by, this is 4 pi square m k z square. So this is the expression for the radius of nth orbit, or let me write Rn, the radius of nth orbit of the hydrogen atom. Okay, now let us substitute the values of all the terms in here. We have, see, we have the value of h is equal to, that is Rn is equal to n square into, the value of h is actually Planck's constant and it is actually 6.636 into 10 raised to minus 34 square divided by, we have 4, pi is actually 3.14 square, and the mass of electron is 9.1 into 10 raised to minus 31. And we have K, the electrostatic force constant, and its value is 9 into 10 raised to 9. For hydrogen atom, we know its atomic number is 1, Z equal to 1, and the charge of electron is, I just took the general expression here, Z. Okay, actually the atomic number of hydrogen is 1, and we know the value of the charge of electron is 1.6 into 10 raised to minus 19. Charge of the electron and proton are the same. Okay, plug in all these values in here, you will get M is 9.1 into 10 raised to minus 31 into 9 into 10 raised to 9 into Z is actually 1 into 1.6 into 10 raised to minus 19 square. Simplifying this, you will get Rn equal to 5.3 into 10 raised to minus 11. See, the value on simplifying this, you will get 5.1 into 10 raised to minus 11. There is an n square here, n square. So this is a general expression for the nth orbit of Bohr model of hydrogen atom. Or you can write this as see, we have 5.3 into 10 raised to minus 11 equal to 0.53 into 10 raised to minus 10. Okay, so that will be 0.53 angstrom, A0, because 10 raised to minus 10 is angstrom. See, the unit of this one is actually meter. Radius basically means the length. So this can be replaced with angstrom, so that I can write radius of the nth orbit equal to 0.53 n square. The unit is angstrom. Clear? Now we call Bohr radius when n equal to 1. That is the radius of the innermost orbit. That is called actually Bohr radius. Actually n is equal to 1, the radius of the innermost orbit, so that I can write R1 is equal to 0.53 times 1 square angstrom. That is actually R1 is equal to 0.53 angstrom. Clear? See, some others take this as R0. Okay, both are correct. They are just the representation. You can take any of these representation. Now, so this is the Bohr radius. And one more point, from the expression itself, it is clear that Rn is proportional to n square. Okay.